Good morning, everyone. It's 6 a.m. in Pennsylvania, and I welcome you to the third edition of DigiPath Digest. When you log in here, let me know when you are tuning in from. Give me a hi and where you're at right now. So let me tell you a story. Of course, I have my beautiful, fantastic new camera here that didn't work. So I'm just doing my normal computer camera. But let me know where you're tuning in from. I see you're joining. And let me just say hello in the comments and welcome you. We have a few abstracts today, 3. Oh, Erika, so great to have you here. Hello. And Robert, you made it from Maine. Yeah. So there was a little bit of a glitch yesterday. I think I had it initially for yesterday at 6 p.m. And it's always at 6 a.m. in the morning. But Robert sent me a message that, hey, is it yesterday or today? It's today. And we have Jason from Baltimore. Baltimore is not that far from me. It's 1.5 hours. So fantastic to have you here, guys. I know there's going to be more people joining, but for those who already were here on time, here, agenda, guys, I'm serious. So for those who are here but don't know me, I'm Dr. Alex Zuraw, and I'm a veterinary pathologist and the founder of Digital Pathology Place, and I'm on a mission to teach you all you need to know about digital pathology. And part of this mission is my book. If you didn't grab the book yet, there is one when you go to my website, digitalpathologyplace.com. You can download this one for free. And let's dive into, one question before, because so now what I'm doing, I'm reviewing the abstracts that come from PubMed alerts, but I also discovered this software for literature review, literature research called Undermind. I showed it to you last time, but I'm going to share it with you one more time because I want to ask you something. Stop screen and share screen. So Undermind, you should see it now. So this is this research engine. So this week I had a ergonomic training, and welcome, ergonomics training at work. And I was like, okay, I'm working remotely, so I do have some stuff. I have like standing desk, I have the walking treadmill for things, because when I started working from home and I have the watch and I have the ring to measure my activity, the activity goes a lot, like it's so much less than when I was actually driving to work and I had to go from my car to somewhere. Anyway, and welcome, Milena from the Netherlands. Great to have you here. Anyway, so long story short, with this tool, Undermind, you can do research on a specific topic. And I did a research on pathology, digital pathology ergonomics. So if this is something you're interested in me covering, I mean, I'm going to cover this at some point anyway, but if you're interested in any other topics, leave me a comment what topics you're interested in, like specific topics, like, I don't know, the scanners or the AI models that are available open source or something, whatever you're interested in. And hi to India. And welcome, Ahmed from Saudi Arabia. Great to have you here, guys. So any topic that you think, oh, I would need, like, I would want something specific to that, not just what comes from PubMed every week, but just specific to that particular topic, let me know in the comments the topic. And without further ado, let's move to our abstracts. Need to share a different screen, which is my tablet, where I can also draw, right? Yes. Okay, perfect. So today, the first topic is AI-based digital pathology provides newer insights into lifestyle intervention-induced fibrosis regression in MASLD. So this is liver fibrosis. I'm going to explain everything to you. But something that's interesting, I'm looking where these publications come from, not only geographically. So this one is from China, but what kind of journals they are in. So this is like a liver internal medicine journal. There are a few that we don't have in pathology journals today, and they are from other disciplines where people use digital pathology and publish there, which I think is cool because this like spreads digital pathology from this niche of pathologists, because pathology is the gateway to diagnosis, and that's why I'm happy about that. So what do they say here today? Lifestyle intervention is the mainstay of therapy for metabolic dysfunction associated steatohepatitis, so MASH. This is what we're talking about. And fibrosis is a key consequence that predicts adverse clinical outcomes. So when it goes very bad, you have liver fibrosis. I want to make it even bigger so that you can see this. Anyway, so what they did here, they did imaging of biopsies, of pre-treatment and post-treatment biopsies. And I'm going to tell you what the treatment or like what the intervention was. But they used a different method than just our standard H&E. They used harmonic generation 2-photon excitation fluorescence microscopy with AI image analysis. So it's a non-staining method. You excite the surface of the sample and you image it. You image the fluorescence, and the method to calculate the level of fibrosis, they called it Q fibrosis. And this provides qualitative assessment. And so I thought that was also interesting because the non-staining methods are getting more prevalent. And if you've just joined, because I see the number of people joining and unjoining fluctuate, be sure to say hi and be sure to let me know if there is a specific topic you would like to cover in one of these journal clubs. So they examined those unstained sections, so here's the keyword, unstained sections from paired liver biopsies, baseline, and end of treatment intervention, so pre and post. And they had something that is called routine lifestyle intervention and strengthened lifestyle intervention. And they actually saw fibrosis regression, which I think is a big deal because fibrosis is like one of those processes in pathology that doesn't go away that easily. But they saw it with this lifestyle intervention. And they basically say that using digital pathology, they could detect more pronounced fibrosis regression. Congratulations to them. Let's see, where is it published? We already checked in the Liver Internal Medicine. Okay. So that is our first abstract. Without staining. I think this is cool because so I told you the other day, or I keep telling people that I was super excited about the molecular predictions. And for a long time, like 34 years, it was like only academia, only research, nothing into the clinic, until there was a publication in 2023 that something actually made it in the clinic. And the other thing that I'm super excited about is the stainless imaging, direct to digital imaging. Sometimes you can do direct to digital from tissue like immediately without even fixating the tissue, just like cut it or freeze cut it or different methods. And sometimes you need to fix it, but you don't have to stain it. So anyway, in each of these options, you skip some of the analog steps of pathology, of digital pathology. You go direct to digital, and that's something that is super like a huge advantage of digital pathology, because radiology and all the other digital imaging, they have it. They don't have to go to analog and then to digital like pathology. And I'm like, okay, until that goes away, we're not going to be as good as the other ones, but we are as good as the other ones, but just have glass slides. Okay, now moving on to our next abstract, which is artificial intelligence for, artificial intelligence for detection of prostate cancer in biopsies during active surveillance. So I assume the male people know what that is, but I checked, like, what's the difference between active surveillance and treatment. And basically active surveillance is when you are not treating, you're just monitoring and you're checking. You still do biopsies pre and post at some point. Sorry, no, you do the first biopsy and then you have the results that are telling you that there's no cancer or inconclusive or like low. There is a specific Gleason score for that. And that's active surveillance. You don't do prostatectomy, you don't treat, you just monitor. And what happened here, they use an AI algorithm, which to me it was like, okay, well, we even have an AI algorithm that is cleared by the FDA for prostate. So that's kind of like not that novel. And let me check the journal again, because this one was also, so I didn't know this journal, BJU. This is the British Journal of Urology. So this is, again, a non-pathology journal that is actually publishing about digital pathology and has the keywords digital pathology. So they evaluated cancer detecting, the objectives were to evaluate a cancer detecting artificial intelligence algorithm on active surveillance. So they had, and this is a group from Norway, they had 180 patients in the Prostate Cancer Research International Active Surveillance, PRIAS. Did I tell you that pathology likes those abbreviations? I think last time I told you. So they had diagnostic, so the initial diagnosis, initial biopsy, and let me zoom in, and the re-biopsy slide. So they had two biopsies, and the dates were from 2011 to 2020. And they had a lot of these biopsies because they had 4,744, and they were scanned and analyzed by an in-house AI cancer detection algorithm. So they developed their own. They didn't use any commercial tool. They just developed their own. And what happened? Also, they were then the goal was that to analyze this this algorithm for sensitivity, specificity, and accuracy to predict the need for active treatment. So their surveillance, and if there is a need for active treatment, then we treat. What's the prediction? And other prognostic properties like cancer size, prostate-specific antigen PSA level, and a PSA density and diagnosis were evaluated, and the results were, and this particular algorithm had the specificity of a sensitivity of 0.96 and specificity 0.73 respectively. And their reference method to check how good it was the original pathology report diagnosis. So that was what they were comparing against. And the conclusion is that this cancer detection algorithm could be used to reduce pathologist workflow. So could be used, I would have to go into the original paper and see, okay, like, are they planning to use it, or did they just have the good specificity and sensitivity and specificity to use it, I guess. But basically it could be used to reduce pathologist workflow in the active surveillance cohort. And the detected cancer amount correlated with the cancer length measured by the pathologist, and the algorithm performed well in finding even small areas of cancer. Are we like suggesting here that we run this algorithm and then the pathologist just checks and we have like a screening tool? I think that would be cool. So, and what they say is that to their knowledge, this is the first report on an AI-based algorithm in an active surveillance cohort. So normally it's just like diagnostics, but here they were doing this active surveillance and it worked. It worked. So the third paper today is from scientific reports, and scientific reports is part of the Nature portfolio. So these, when I look at these papers, they're usually like very impactful and pretty complicated, but that's okay. It means, and this group is from Wuhan, China. Wuhan, China, published in scientific report. So the title is Matrix Metalloproteinase 9 Expression and Glioblastoma Survival Prediction Using Machine Learning on Digital Pathology Images. So let's start with what are these matrix metalloproteinases and why is this expression important? So these are enzymes that they change the tumor microenvironment. For example, they can digest proteins, digest collagen, and restructure, rebuild the tumor microenvironment, for example, the tumor stroma. And what's happening in the microenvironment is often important for prognosis. But this is an interesting setup as well because they applied, so the study aimed to apply pathomics. I'm like, pathomics? What do you mean with pathomics? What is this? And pathomics is like using pathology, expression data, and like multimodal data, including pathology. So they will use this pathomics to predict matrix metalloproteinase expression in glioblastoma and to investigate the underlying molecular mechanisms associated with pathomics. So I like heard this word, but I didn't know it was like an official word. I had to look it up, guys. So they had 120 glioblastoma patients, and 78 of them were allocated to the training, randomly allocated to the training and test cohorts for pathomics modeling. And so then they calculate the prognostic significance of this matrix metalloproteinase. So just to give you a little bit of context, the normal way of measuring this is RNA expression, the RNA levels. So you have to destroy the tissue and find what the levels are, right? So here they used pyradiomics. They used pyradiomics. I'm going to tell you what pyradiomics is because I had no idea. I had to look it up for you. Pyradiomics was used to extract the measures of H&E stained whole slide images. And I'm like, pyradiomics? What is this? Apparently, it is some open source model. I want to read you the real definition. Pyradiomics. It's an open source model, open source Python package for the extraction of radiomics data from medical images. I'm like, okay, that's pathomics, but they use radiomics. I guess it worked well as well. So anyway, they did feature selection and used different parameters, and they created prediction models using support vector machines and logistic regression. And they assessed the performance and what they stated. So the performance was assessed using ROC analysis, calibration curve assessment, and decision curve analysis. And the MMP9, the metalloproteinase 9 expression was elevated in patients with glioblastoma. So, and this was an independent prognostic factor for glioblastoma. So this is like independent thing. And they had other different features, but I went into the introduction of this, and basically what they did, they used the TCGA, Tumor Cancer Genome Atlas, and another database to train this model against the RNA levels. And then they used RNA levels for metalloproteinase. So pretty fancy. Another thing that gives me like hope, I don't know if hope is the right word, but basically another thing where you can predict something from the image, and the image is always there. The image is part of your pathological diagnosis. So one part is okay if you can do some imaging without the slides. That's fantastic. That's like the next level. It would be something that you will be using for intraoperative procedures. I don't know, maybe something on the skin where, I don't know, something where you would not need to take out this sample. But for this type of diagnosis, the pathology on glass is often going to be the thing that's going to be still going to be used, and this image is always there, right? So if you can avoid some downstream tests, or if you can guide or narrow down the tests that you're going to be doing with after the pathology is already done, after the biopsy is already taken, that's all power to you, right? Fantastic. So this is another thing where they did that and published in Nature. And these are the three ones that, no, there is one more that I want to share with you. It was interesting because I was looking, so the title of the next one is 1 million segmented red blood cells with 240K classified in 9 shapes and 47,000 patches of 25 manual blood smears. So it's an interesting title, right? They had 25 manual blood smears, and they managed to have all those thousands of pieces of data. And this is also scientific data. I'm checking here. This is also Nature Portfolio. I'm like laughing at this title because it's more like a marketing title for people to click on. But, that's a good enough title for scientific data. And this group is from Egypt. And this is actually a group that has a commercial entity, Pathologics. I was looking up this company. If anybody from Pathologics is listening to this, feel free to reach out to me on LinkedIn. In great publication, but I couldn't find the website of this company. But oh, my computer is acting out. Okay, so what happened here? I want a different color. I want a green. Okay. So 20% of complete blood count samples necessitate visual review using light microscopes or digital pathology scanners, right? We can scan as well. So there is currently no technological alternative to the visual evaluation of red blood cells, which I thought was interesting because I thought that the blood analysis, but I think it's white blood cells, like all these morphologies that the AI algorithms actually started in cytology to differentiate white blood cells and different blood cells from each other. So I was surprised to read this, that there is no technological alternative for red blood cells morphology shapes, so the erythrocytes. Um, so and what are the problems with erythrocytes? Um, true, sorry, wrong pen. There is true non-artifact teardrop-shaped red blood cells, and schistocytes or fragmented red blood cells are commonly associated with serious medical conditions and can be fatal. And then increased ovalocytes are associated with almost all type of anemias. Interesting. So what they did, they took 25 blood smears, um, and each of those blood smears was from a different patient. Then they were manually prepared, stained, and sorted into 4 groups, and each group underwent imaging using different cameras integrated into light microscope with 40x microscopic lenses. So they did it with microscopic camera. They didn't do this with scanning. And what happened then was that they had a lot of patches. So because with the microscopic camera, you probably have to go field of view by field of view by field of view, and they had a lot of patches, 47,000 plus field images or patches, and then 2 hematologists processed cell by cell to provide 1 million plus segmented red blood cells with coordinates and classified 240,000 of red blood cells into 9 shapes. So we have classification of 9 shapes, and this is um, manual data labeling. And they created a data set, El Safti RBCs for AI. And El Safti is one of the authors of this paper. And then you can you have this data set that enables the development of testing and deep learning automation for red blood cells, morphologies, and shape examination. And you can also include specific normalization for blood smear stains. So the blood smears and the cytology, these are slightly different stains than the H&E that we are all used to. All who look at tissue are used to, and pathologists a lot. So they prepared this data set, and they provided also codes for codes, meaning the code. I don't know which coding language they used, but one was for semi-automated image processing and another for testing of deep learning-based image classifier. So that is interesting. Guys, which one do you think is most interesting? Liver, blood, or what else we had? Prostate active surveillance and see, I don't even remember what we talked about, and I just finished talking about it. And glioblastoma, the metalloproteinase. If you have a favorite, give me a 1, 2, 3, 4. In the meantime, thank you so much for joining, but I want to tell you a few more things today. So what's up in general in life? I'm going to Poland in August, so I don't have the live stream scheduled for August yet. I probably will skip 1 week and have it. No, I think I'm going to keep it at the same time because in Poland it's 6 hours difference, so it's going to be 12 o'clock my Polish lunchtime. It's still going to be 6 o'clock for everybody who is in the same time zone as I am right now. So that's going to be happening. You will see a different background behind me. And then another thing I'm working on, let me know if you're interested in this. It's gonna be, I have a bunch of YouTube videos, as you know. It's like almost 370 or over 400. And so anytime there was a topic I wanted to explain, I would make a YouTube video. And one of my membership Digital Pathology Club members suggested, hey, could you like embed those videos in a kind of curriculum? And I am looking for a way to choose my YouTube videos. So this is, everything is already available for free, but I want to have a little small option, like a paid version where they are systematized in the curriculum. That's going to be something that is less investment than my Digital Pathology Club membership, which is at 97 a month. This is going to be like a one-time course fee. So if this is something interesting for you, give me a comment, say YouTube course, and I'm gonna gauge interest. How many of you are interested in that? In this, it's like I call it mini course, but it's not gonna be mini course. It's gonna be like comprehensive curriculum, but from videos that are already available for free, that are gonna be systematized, maybe some additional resources. And I will need to host it somewhere so that it's not. I mean, the videos are gonna be the same, but I'm gonna host it somewhere where you don't have to scroll through YouTube, but it's gonna be a dedicated page. So if this is of any interest, drop a comment, YouTube course. And another cool thing that I witnessed or was part of, I was just listening to it. There was AWS, Amazon Works Services. What does AWS stand for even? I know it's Amazon for cloud, right? AWS. What is it? Amazon Web Services. Yeah, Amazon for Cloud Web Services. They had a summit in New York, and there was a part of this summit where they were announcing different collaborations with different people, different businesses that you could register for and listen to. So there's a lot going on with generative AI, right? So by the way, if generative AI and ChatGPT and stuff like that is of interest, and drop me a comment below as well, that this is a topic of interest, and then I'm going to go into Undermind.ai and do a specific search for that, and then we're going to go through papers on that particular topic. I remember giving a webinar last year where there were no I was explaining ChatGPT, and you can find it on YouTube as well. Maybe I'm going to link in the comment. But basically, there were like, I was doing literature research and there was nothing out. And now every week there is something new, pretty high publication. It was tested how pathologists would like to use it. So if that's a topic of interest, give me a comment, let me know. ChatGPT or generative AI, whatever you want to put in there. So what's happening? They are working, AWS is working with Anthropic. Anthropic is like a, I don't know if they're, I assume they're a competitor to OpenAI. They have this other model, Claude, in contrast to ChatGPT. And I use both, by the way. So they are working with Claude. They're working on solutions for enterprises that are secure, that are being able to be fine-tuned and just use your secure company data without leaking everywhere. So a lot of business solutions that will help different type of businesses get leverage. And I, of course, was on the lookout for anything in the biotech space or pharma or pathology. And I've heard that Pfizer is already using Anthropic for something. I was looking for some press releases, and it only says that they are collaborating and doesn't really say what they're doing with it. I couldn't figure that out. And okay, Erica, perfect. You want the Chat GPT version. If anybody else, let me know, because then I can prepare something super specific. If you have any other topics that you would be interested in rather than just the abstract reviews, let me know in the comments. And in the meantime, you have a wonderful rest of your day, and I talk to you in the next episode.